All right, today we're going to use partial products and distributive property. All right, you will have some homework tonight. Hopefully it won't be a lot. Let's pay attention. That way we can make sure that we do the best job that we can possibly do on our homework and everything else that we do today. All right. So first things first. What strategies can be used to multiply whole numbers? We've talked about this. We've used different strategies to multiply whole numbers. And I can tell by your guys' faces that this might not be one of the things that we remember, or that you even realized that you were learning. But how about, what are these things called? Where we made? What was that thing called? Yes, Miss Hess, since you've already yelled it out. So what would this array represent? What multiplication problem? Sammy? 3 times 3. So this would be 3 times 3 equals 9, right? So we count on 1, 2, 3, 4, 5, 6, 7, 8, 9. There's 9 dots there. Very good. Okay. So can anybody think of a different way that we could have done this? Yes, sir. Well, we just did that, right? We just did 3 times 3, which is right here. So there's our 3 times 3. Ooh. I wasn't supposed to be able to do that. Undo. I thought that I locked this. Control Shift L. Ooh, I didn't lock them. All right, I'll have to fix that on the next one. Cool. Yes, sir. 9 divided by 3. Okay, what if we just made groups? Okay, so we used an array, right? So now this is telling us that we have 3 groups of 3. So there's 3. That's one group. Here's 3. There's another group. Here's 3. There's another group. So that's 9. All right. So it's different strategies that can be used. So we have arrays, groups. They're kind of the same thing, but we'll go over some more as we go. All right. So here's our problem of the day. We'll do it together. It says admissions to the zoo is $5 for an adult and $3 for children. A group spends $19 for admission. How many of each kind of ticket did they buy? Write how you solve the problem. So the first thing we need to figure out is the way this is going to work is we have $3 and we have $5, and somehow all of it is going to be equal to $19, right? So how are we going to get started here? Yes, sir. 3 times 5 is what? That's not 19. Close though. All right. So let's see if we can figure this out. The first thing that I would do is I'm going to look for multiples of 3 and multiples of 5 that I can break this number into. Jedi.
3 times 5 plus 4.
No, we can't do that. We can only use the numbers that we have sitting in front of us. Now, we can use the $3 is for children. So how many children are we going to take in? And then the $5 for adults. But before we get there, I want to take this 19 and I want to separate it into 2 different numbers. One that I can make with 3s and one that I can make with 5s. Yes, ma'am.
We can do 3 times 3 and 5 times 2.
And that's going to give me what?
5 times 2 and 3 times 2 will give you 9.
Okay, so what I was looking for is just the 9 and the 10, right? So we have 9 and we have 10. So you said that my 3 times 3 is going to give me 9, and 5 times 2 is going to give me 10. Correct? Okay. Now that we've established that, what we actually need to do is put these together. Okay? So we're going to go 3 times 3, 5 times 2, and we're going to add those, and that equals 19. Okay? Now, how many of each kind of ticket did they buy? Well, the adults were $5, so how many adult tickets did they buy? How many adult tickets did they buy? Class?
2.
2 adult. Then the kids were $3 for children. So how many children tickets did they buy?
3.
3 children. Okay. So you guys see how we did that? We took the 19 and we broke it down into 9 and 10. Then we created a problem with 3 times 3 equals 9 and 5 times 2 equals 10. And that gave us our 19. Okay. Listen, math is really simple if you do small problems. This up here, if we tried to do this all at once, this could be difficult. But because we made it 2 smaller problems, made it pretty simple. Okay? So that's what we want to do. We want to figure out what we can do to make things easier. All right? So 2 adults and 3 children. Very good. Okay. This is inside your textbook, so make sure you're filling it out as we do it. All right? These are your notes for tonight. It says Darnell and his 4 friends went to the ice skating rink and bought sandwiches. They divided the total cost and found that each person needs to pay $17. Wow. What was the total cost for ice skating and sandwiches? Okay, I used to go ice skating a lot. I mean a lot. It's kind of what we did when I was in, I think I just started driving, because the ice skating rink was the way that we could stay out the latest because it was open the longest. I think it was only like $4 to get in, and like, yeah. I could go to the ice skating rink every Friday night for like $10. You guys, good luck getting 17. All right. Sorry, couldn't help myself. Now, he has 4 friends, right? Darnell and his 4 friends. So how many of them are there total?
5. Sorry.
It's all right. Just raise your hand, Wyatt. Okay. So Darnell and his 4 friends. How many kids total? Yes, ma'am. No, we're not there yet. Darnell and his 4 friends. How many kids are there total that they split this cost of? Yes, ma'am. There are 5 kids. Okay. Now, with those 5 kids, each one of them paid how much money? $17. So each one of them paid $17. Okay? Now, how we broke our thing apart in our last problem, and we broke it to 3 and to 5. So 3 times 3 and 5 times 2. What they want to do is they want you to break down the 17 to 10 and 7. So 5 times 10 is 50. And then 5 times 7 is
35.
35.
And then it says they want you to add the partial products. So we have 50 and we have 35, which equals 85. Why do you think that they did this? So our total cost was $85. Why do you think they want you to break them down? Yes, sir.
They want to make it more challenging, even though it's simple.
More challenging even though it's simple?
Yeah.
So 5 times 10 is harder than 5 times 17.
No. No. They want to make it easy.
Probably.
They want to make it easy.
Okay, by making it two, this is what they did. They took one problem and they broke it into 2 easier problems. That's all they're trying to do. Okay, so we're going to spend this entire time looking at word problems and trying to determine how we can break them into smaller, easier problems. Okay, so congratulations, there's your answers. You guys did it. Okay, and now we're going to label to find the partial products. We have 50 plus 6. So check this. This is the area model, okay? This is what they call the area model. They took 56 and they broke it into 2 numbers, 50 and 6. Then they take 7 and they put it over here, right? What they want you to do is fill in the squares with the numbers that belong there. So 7 is going to be inside of both of these areas. So we need a 7 here and a 7 here. Okay? Now 50, do you see the little the squiggly line on 50 here? Okay? So 50 only belongs in this box here, in this area. Okay? So it's going to be 7 times 50 there. Then over here, only the 6 belongs. So it's going to be 7 times 6. Okay? So we're going to multiply and then add. So down here in our next section, it says 7 times 56 equals 7 times 50 plus 7 times 6. Okay? Now, the first number is always going to have a 0 in the ones place. Why is that? Why does that make it easier to do 2-digit multiplication if there's a 0 in the ones place? Yes, sir.
Because so it's easier because if it's like 25 divided by 7, it's going to be harder for you to multiply.
There's a trick or a rule that makes this easier. If there's a 0 in the ones place on 2-digit multiplication. Yes, Jedi.
7 times 50 because it's easier because it'd be 7 times 0, then you just have to do 7 times 5 and the 0.
This 0 just drops down. It's there. Then 7 times 5 is 35. Right? So what we're not having to do is if we did 56 times 7, 7 times 6 is 42, carry the 4, so we regroup. 7 times 5 is 35, plus 4 is 39. So see how we had to regroup up here? By putting a 0 here, we eliminate that. Okay? Really, it's a good way to check your problems as we go on. Okay? So we have 7 times 50 is 350. And 7 times 6 is? What's 7 times 6? 42. And we add those together and we get 392. All right. So
So there you go. Good job. Okay. We're going to do some of these together. You're going to do some of these on your own. Okay? Number 1, it says mathematical practice. Draw a conclusion. How do area models show partial products? So what about an area model makes it show a partial product? Don't everybody try to answer at once. Area models show partial products by, what do we do with the area model? What do we do with the 2-digit number that creates an area model? Yes, sir. We're not multiplying the 2-digit number. What do we do to a 2-digit number that creates the area model? Nobody knows how we break it apart. Okay. Tens and ones. By breaking a 2-digit, typo, number into tens and ones, then multiplying them by the same number. Okay, so in finding 7 times 56, what does the area model separate? Why does the area model separate it into 50 and 6? Why do we separate them into 50 and 6? Why do we break them down that way? We discussed this a little bit earlier. What are we trying to do with the area model? Do you remember what I said we get to eliminate? Yes. No, that's not what we're eliminating. What do we get to eliminate? Miss S? Yes, because by putting a 0 in the ones place, you eliminate regrouping. Okay? Which is also creating 2 simpler we'll say easier multiplication problems. Alright, the idea is to create easier math problems. That's the idea. You look at a difficult problem, you say, okay, how can I break it down to make it easier? Alright, we're not trying to make things more difficult, we're trying to make things simpler.
Okay, how do we make things simpler? We break them into problems that we know how to do, and we can do with our eyes shut, and all of our work with our math facts and stuff will come into effect. Okay, so here we go. Now the last one says find 6 times 36 using partial products. Label the model to help you solve and show your work. I'm going to help you label the model, and then you're going to work on your own. Okay? Which number goes here? Class?
7.
7. This is the problem that we are going to break down. So, I think you were still looking at number 2. We're on number 3 now. Okay, so which number is going here? 6. Now, what number goes into this first box over our first area? Class?
36.
Ooh.
30.
30. It's the tens place with the 0, which means 30 plus what equals 36? 6. So that means 6 goes in this other box over here, correct? Okay. Now, I'm going to give you guys a couple minutes to work on this on your own, and then we will come back and we will double check our answers. This is up. All right, let's fill in our area model. What goes in this first square that I'm looking at right here? 6. Help if I had a pen. All right, so that's 6. 6 times what?
30.
And then what goes here?
6.
Times what?
6.
Okay. Now, the way that I like to do this is just go boom and put an addition sign down here. So 6 times 30 is 180. And 6 times 6 is?
36.
So 180 plus 36 is 216. Now, over here, it says label the model and show your work. So what they wanted you to do is fill in this whole model and then put the 180 plus 36 equals 216 over here. But like I said, I like doing this because this is the way that we show our work for everything. I mean, everything that we've done so far, any kind of order of operation, we've always put our little V's under there and dropped our answer down and rewrote the whole problem, right? Okay. So if you want to show your work like this, that's fine. All right. Moving on. Okay. You guys are going to do the practice. Number 4s, 5, 6, 7, 8, and 9. Actually, all the way through 12. All right. And that will be your homework for tonight. If by chance you get stuck on something, the answers will be on our video on YouTube. So you have 9 problems to work on. At the end of the YouTube video, which is off of our classroom website, all of the answers will be there. I am going through them now. So if you get stuck or you're not sure about something, you can go look. Remember, the answers are one thing, but what must you do? You must show your work.